This work presents an intuitive shape editing framework for man-made models. We introduce component-wise controllers, which allow for fast, meaningful shape editing with simple user interaction. During editing, structural features are automatically preserved. Here's another example. Compared to iWire, our technique largely decouples modeling complexity from geometry complexity, providing a more intuitive editing interface. To construct the component-wise controllers, the 3D model is first decomposed into meaningful components. Each component is then associated with a controller, which is a primitive adapted to the component geometry. 4 types of primitives are included as controllers, namely sphere, cylinder, cuboid, and generalized cylinder. Each type of primitive has a predefined degree of freedom. For example, a sphere can undergo similarity transformations. Cylinders can be scaled along its main axis or radially. Cuboids and generalized cylinders also have different degrees of freedom for editing. Such design provides intuitive editing guidance to protect the underlying component geometry. Our system automatically identifies the mutual relations among the constructed controllers, such as symmetry, concentricity, coplanarity, and parallelism. The user may modify or add relations if desired. Automatic preservation of these mutual relations is the challenge of this editing paradigm. During editing, the user directly manipulates one of the controllers, and the edit is automatically propagated to the rest of the controllers based on proximity. The relations among the controllers are automatically maintained. Finally, the updated controllers are used to reconstruct the underlying object. Now we show how the edit propagates over the controllers. Starting from the controller under direct manipulation, all its symmetry controllers are first transformed accordingly. Then the propagation proceeds to other controllers according to proximity. Each time, the closest controller is identified and updated according to its relations with the already treated ones. Let us now introduce more implementation details. We delegate the definition of mutual relations among controllers to their feature curves. Feature curves are simple curves that define the controllers. They are either circles or rectangles. For example, a sphere has one circular feature curve, while a cuboid has 3 rectangular feature curves. Given such definitions of feature curves, our component-wise propagation can essentially be achieved by first updating all feature curves of a controller before moving on to another controller. For more details, please refer to the paper. Our system supports hierarchical controller organization to facilitate easier editing. The controller hierarchy is formed by a series of grouping operations. During editing, the user manipulates only the top-level controllers. The edit is automatically propagated first to other controllers at the same level, then down to the lower-level controllers, and finally to the original geometry. Such controller hierarchy minimizes the number of controllers that the user needs to directly manipulate. For example, we only need to manipulate one controller to achieve resizing effects while still preserving the structural features. To achieve different editing effects, our system allows the user to specify or change mutual relations among the controllers. For example, here a reflective symmetry relations is not detected between the controller of the front and back tires. Now the symmetry relation is added, and a different editing result is obtained. In this example, symmetry and coplanar relations are detected between the controllers of the front and back boards. These relations are maintained during editing. Next, the user chooses to break these relations. The same editing operation now leads to a different result. In this example, no coplanar relation is detected between the front and back parts of the vehicle. Now the user assigns a coplanar relation between the two parts. Lifting the front end now leads to the back end being lifted as well. We now show more interactive editing sessions with our component-wise controllers.